today I'm going to be doing the editorial for problem H, grid 1 of the AtCoder DB contest. Okay, let's look at this. We have some grid, and we have, W, H, rows and columns. Okay, so each square has a dot or like a pound sign, and some guy starts at the top left corner and tries to read the bottom right. And you can only move right or down, okay? And you're just trying to find the number of paths from the start to the end, and you just have to do a modulo because apparently the number is quite big. Okay, and H and W are 10,000, so we should be able to do n squared here. Okay, so let's look at this. Let's just try to see what we can understand from this problem here, okay? So you have a grid, you're moving around, right? So let me try to draw this at least okay here. This is covered, and you can't go in this square either, okay? And you can only move right or you can only move down. So immediately what we know is there's no cycles, right? So you can't go like back, okay? You can't go back. So what we can see out of this, if you can only go down and right, meaning if you have a cell, right, that Taro is on, we know he either came from right or up. So essentially the last place this guy was at is either the cell above him or the cell to the left of him, right? Because if he was in this cell, he would have moved right, and if he was in this cell, he would have moved down. Okay, so that's two options, right? And obviously if there's this cell, then like we just can't go there. So, okay, so if Taro was in this cell, his only option was coming from this cell. Okay, so given those observations, right, there's no cycles, and if Taro was at one cell, we know that he came from any one of two cells. So then we already start to think of a DP, right? How do we solve this problem given like simpler problems from the past? Okay, so given any cell, right, let's say it's this cell here that Taro is at, how do I find the total number of paths, right? So I know he either came from here or from here. So essentially what it is, it's just the number of paths here. So the number of paths for this cell, cell A, versus the number of paths for cell B. And so it's just, paths of A plus paths from B. Okay? So so this is exactly what you do from a DP, right? You want to solve your problem using smaller problems. So if we have a DP, which is, say, given Taro is currently at cell IJ, what is the number of paths, right? Possible number of paths, of course, with my modulus. So all this would be, it's the DP of I minus 1 J, which is, the one to the left of him, so, moving right from this cell, plus DP of I and J plus 1, right? Which means that his last move was moving downward. And that's basically it. And all we need to check is if either of these, right, the grid of I minus 1, or the grid of I and J minus 1, if these are equal to pound, then these values are 0. And that's it. So all we have to do is we loop over ij, right, for I, 0 to n, for j, 0 to m. We just do this, right? We just do dp of I minus 1 of j and plus dp of I and j minus 1. Sorry, j minus 1. Maybe it would be easier, if you do it one indexed, right? Because then you don't have to deal with it being negative, and all you initialize is you initialize dp of 0 and 0 to be 1. And of course, what you have to take care of the bounds is if dp of I j equals pounds, then dp of I and j is equal to 0, right? Simple as that. And there you go. That is how you solve this using dp and your complexities of nm, which will fit the time complexity. I hope you can see through the dp thought process through this editorial, and I hope it helped you. Thank you for watching, and I'll see you next time.